Welcome back, everybody, for another deep dive. This time, we're going all the way back to 2012.
Oh, wow.
Yeah, 2012 to take a look at open source physics education
Okay.
in Singapore.
Cool.
Our source material is a web page snapshot
Right?
from Open Educational Resources / Open Source Physics at Singapore,
Mm-hmm.
a website completely dedicated to just that.
What's really fascinating about this website is that their goal is to create a world where teachers and students can have access to high-quality physics simulations without having to,
Spend a fortune.
spend a fortune. Exactly.
It's so true.
Yeah.
Imagine getting rid of all that expensive software,
Right.
but still being able to explore physics
Yeah,
in this hands-on way.
absolutely.
That's what this website and all the people behind it are really striving for.
It's really cool.
Now, the web page that we're looking at is like a little snapshot in time,
Okay.
January 11th, 2012 to be exact.
Right.
And it actually documents this sharing session at the S5 Cluster Science Support Group meeting.
So it wasn't just like a casual get-together.
No.
It sounds like we have educators from different schools
Oh, yeah.
and institutions all coming together.
Yeah, they were excited about it.
Yeah, to share,
This new approach.
to teaching physics.
I bet the energy in the room was amazing.
Oh, I bet.
It seems like they were at the forefront of something big, you know?
Right, totally. And speaking of the people involved,
Yeah.
we see names like Matthew Ong,
Oh, yeah.
Wilu Kang, and Sei.
They're really passionate about making physics education accessible.
Clearly, yeah, and get this, the session focused on adapting complex physics simulations
Wow.
for primary school students.
Starting them young.
I know, right?
Wow.
It's about sparking that love for learning early on.
It makes sense, though.
Yeah.
If you can make physics fun and engaging,
Right.
who knows what these kids could achieve.
Exactly.
At the
Amazing.
time.
So a key player in this session is something called Easy Java Simulations,
Easy Java simulation.
or EJS for short.
EJS.
Yeah, think of it as like a digital playground for physics.
Okay.
It's this free open source software that allows anyone to create and share
Interactive.
interactive physics simulations.
Hold on, open source.
Yeah.
You're going to have to explain that one for me.
Sure.
And for anyone else listening.
Yeah, so basically open source means that the software's code
Okay.
is publicly available so anyone can use it, modify it, and distribute it.
So it's about collaboration.
It's all about collaboration and transparency.
So in this case, it means that teachers could create their own physics simulations
Exact.
and share them
Yeah,
with other teachers, all for free.
all for free.
That's pretty amazing.
I know, and it gets even better.
Okay.
EJS comes with a library of over 2,000 existing models that you can remix and customize.
Wow. The possibilities.
The possibilities are endless.
I'm starting to see how this could be a game changer for teachers.
I know, right?
No more budget constraints.
Exactly.
No more relying on really expensive software. They can really create a customized learning experience.
You got it. And this ties back to the idea of EJS being real,
Oh,
as the source material mentions.
Yeah.
It means that teachers can implement these simulations immediately, no bureaucratic red tape or waiting for approval.
so they can be super responsive to their students' needs.
Exactly.
Adjust lessons on the fly.
That's the idea.
That's powerful.
Yeah, it empowers teachers to be more creative and flexible.
And remember those primary school simulations we were talking about?
Yeah.
The webpage highlights something called a real pendulum model. Applet, as an example.
Yes.
Applet, is that like a small?
Yeah, it's just a fancy word for a small program or a mini application, usually designed for a specific task.
Okay, so tell me more about this real pendulum model.
Well, it was initially created by Wolfgang Christian and F. Escumber, but then it was adapted
Oh, wow.
for primary school use by Looking and MattHatter.
So they took this complex physics concept
Yeah,
and made it accessible for younger students.
exactly a perfect example of that open source collaboration.
That's really cool. How did they adapt it? What kind of changes did they make?
That's where things get really interesting, and that's what we'll dive into in the next part of our deep dive.
Oh, cliffhanger, you've got me on the edge of my seat.
I know, right?
I can't wait to hear more.
It's going to be good.
Awesome.
Yeah.
So before we were talking about adapting that real pendulum model,
Mm-hmm.
applet for primary school students,
Yeah.
what kind of changes would you make
Well,
to a complex concept like that?
you wouldn't want to overwhelm them with, equations and theories right off the bat.
Right.
You might want to make the simulation visually appealing
Okay.
and interactive.
So instead of just watching a pendulum go back and forth,
Right?
they could maybe change the weight of the bob or the length of the string,
Exactly.
see how those factors affect its motion.
It's all about letting them experiment.
Yeah.
Discover things for themselves.
Okay.
Hands-on exploration,
Let's dive back into the web page itself for a second.
Okay.
There's a section on popular tags
Right?
that gives us clues about what visitors back in 2012 were interested in.
Yeah, it's like a little time capsule.
And capsule of interest,
Yeah.
exactly.
Yeah.
What jumps out at you?
Well, right away we see Android/iOS, including handphones/tablets/iPads.
Okay.
With 41 tags.
41, that's a lot.
That's huge.
Even back then, they were thinking about using mobile devices for physics.
It seems that way.
Wow, they were ahead of the curve.
Yeah. Remember, this is 2012.
Yeah.
Way before tablets and smartphones were everywhere.
Makes you wonder what those early mobile physics simulations were like.
Right.
Fascinating. And then right below that,
Mm-hmm.
we see easy Java simulation with 8 tags.
Still pretty popular.
Still a strong showing, for sure.
Yeah.
I feel like we're seeing the early stages of a movement here.
Oh, yeah.
This shift towards open source tools, embracing new technologies in education.
Absolutely. And it wasn't just physics concepts either. Look, we see tags like mathematics with 11 tags and primary school with 5.
So they were thinking about applying these tools across different...
Yeah, across different subjects and age groups.
Makes sense. A lot of physics is rooted in math.
Exactly.
Why not use the same tools to teach both?
It's all about finding those creative ways to integrate these simulations into different learning environments.
This is really cool, peeling back the layers of history.
I know.
Seeing how this approach to education was taking shape.
It's amazing what they were doing back then.
And this is just a snapshot from 2012.
Right.
Imagine how much this movement has grown.
Oh, yeah.
Since then.
I can only imagine.
That's what I love about these deep dives.
Yeah.
It always leaves me wanting to learn more.
Me too.
Explore further. There's one more tag I wanted to ask you about, though.
Okay.
It says Tracker Workshop, October 2015, with 2 tags.
Oh, yeah.
What's that all about?
So that seems like they were also really focused on professional development, providing training on how to actually use these open source tools.
It wasn't just about making the tools.
Yeah.
It was about making sure teachers knew how to use them.
Yeah, equipping them with the skills to really integrate these simulations into their teaching.
It seems like they were thinking about this whole approach to education.
Yeah.
Holistically.
Holistically, exactly.
Not just providing tools, but building a community, fostering collaboration among educators.
Exactly. That's a crucial aspect of the open source movement, right?
Yeah.
Shared knowledge, continuous improvement, and the belief that everyone can contribute.
Speaking of contributions, do you think this open source model could work for other subjects?
That's a great question.
Beyond physics and math?
And that is a question we will explore as we continue our deep dive into the world of open source physics education.
All right, I'm intrigued. Let's keep going.
So you were asking if the open source model could work for other subjects beyond physics and math.
Yeah, could it?
I think it absolutely can. The principles of open source, collaboration, accessibility, and customization, they can be applied to any subject where sharing and adapting resources would be helpful.
Okay, so imagine you're a history teacher.
Okay.
And you find this amazing interactive map of ancient Rome online.
Right.
But it's in English, and you teach in, say, Spanish.
Okay.
If it had an open source license, you could translate that map into Spanish, maybe add some extra content relevant to your curriculum,
right,
and then share it with other Spanish-speaking educators.
Yeah, it's like taking the best resources from everywhere and making them available to everyone.
No more reinventing the wheel.
Exactly.
No more being limited by language barriers.
It's really exciting to think about.
And it's not just about translating existing content either.
No.
Imagine a platform where teachers from different countries could collaborate on creating interactive timelines.
Oh, wow.
Virtual museum tours.
Yeah.
Even simulations of historical events.
It opens up so many possibilities for teachers and students.
But wouldn't there be challenges?
Of course.
How do you make sure all that user-generated content is good quality?
That's a great point. And just like with any educational resource, critical evaluation is key. Open source platforms often have review systems or community moderation to help ensure quality.
Okay.
And teachers themselves play a really big role in vetting the resources they use in their classrooms.
So this open source approach to education actually empowers teachers to be more discerning in how they choose and use resources.
Absolutely. It encourages them to be active participants in the learning process.
Not just passive consumers of prepackaged materials.
Exactly.
As we've been talking, I've been thinking about our listener. What are they taking away from this?
Yeah. What's the most important message?
What do we want to convey?
I think it's about the power of open knowledge,
Yeah.
recognizing that education doesn't have to be limited to textbooks or expensive software.
Yeah.
It can be so much more dynamic, collaborative, and constantly evolving.
And it's a process that anyone can be part of.
Exactly.
No matter where they are.
It doesn't matter your background or your financial resources.
It's about breaking down those barriers.
And making knowledge accessible to everyone.
That's a great point to end on.
It is.
This deep dive has taken us on a journey back to the early days of open-source physics education in Singapore.
We've seen firsthand how passionate people are about making high-quality learning experiences accessible to everyone.
And we've explored how those open-source principles can be applied to so many other subjects.
Creating a world where knowledge is shared freely and constantly improved.
It's inspiring to think about the possibilities.
I think so too. And for our listeners, I hope this deep dive has made you a little bit curious.
Yeah.
And given you a glimpse of the potential of open education.
Maybe it'll even inspire you to check out some open-source resources yourself.
Or even contribute to this amazing movement.
Who knows, you might discover your next learning adventure.
Well, that's all the time we have for today.
Thanks for joining us.
See you next time.